Welcome back to 9th standard geometry class. Today we are going to learn a new topic. Till now we learned about a quadrilateral, parallelogram, all those things and problems related to parallelogram. Now we are going to learn a new topic. It is related to quadrilateral itself, but it is called midpoint theorem. So it is a very important theorem, students. Whenever it comes a midpoint of a triangle, you have to use this theorem. This is a midpoints of the triangle. This theorem is related to midpoints of a triangle. So whenever midpoint of a triangle is mentioned in the question, you have to use this theorem. So let us learn the theorem, students. Now theorem 7.9, this is also called midpoint theorem. What is given in the question? The line segment joining the midpoints of two sides of a triangle is parallel to the third side, and it is also half of the third side. So we have to prove two things here. First, let us draw the diagram, students. First, I will read the statement, half statement. The line segment joining the midpoints. So you have to mark the midpoints of two sides of a triangle. So you have to draw one triangle. Draw one triangle. Name the triangle as A, B and C. You have to mark the midpoints of two sides of a triangle. Any two sides, midpoint you have to mark. So I take the side as AB. I'll mark the midpoint as E, and another side is AC. I'll mark the midpoint as F. So these two are the midpoints. The line joining the midpoint. So I'll join this line. Midpoints of any two sides of a triangle is parallel to the third side. Now which is your third side? These are the midpoints of the two sides. Third side is BC, means which is your line? EF. EF is parallel to BC. That is one thing, and it is also half of the third side. Means EF is half of the third side. Third side is BC. So these things we have to prove. So let us write given. What is given? Triangle. ABC is a triangle. E and F are the midpoints of AB and AC. ABC is a triangle. E, F are the midpoints of AB and AC respectively. AB and AC respectively. So this is given for you. What you have to prove? You have to prove it is parallel to the third side. So to prove what? EF is parallel to what? Third side. Third side is BC. This is one thing. And second thing you have to prove is EF is equal to half of BC. So these two things you have to prove. But to prove this, we need to do one construction. What construction we have to do? Because this is related to triangles, I want a parallelogram here. So like that construction we have to do. So I extend the line EF to somewhat distance, and that this EF is equal to that line. Like that I do the construction. So extend EF and name it as D such that EF is equal to FD. EF is equal to FD. Like that you have to name this. then the remaining parts, corresponding parts are equal. So whichever I want, those parts I am going to take, students. One is I want AE is equal to CD. AE is equal to CD. Another thing is I want this angle. This angle is equal to this angle. Why these two angles are equal? Because they are the corresponding parts. If you go to this triangle is congruent to this triangle, these two angles are equal. Angle A and angle C is equal. Angle E and angle D are equal. But I don't want A and C. I want only E and D. And I want the side A, E and C, D. So I will write A, E is equal to C, D. Another one is angle AEF is equal to angle CDF. This is by CPC. By CPC, I can write these two things are equal. Now, but AE is also equal to BE. Why AE is also equal to BE? See properly here, AE and BE are equal. Why? Because E is the midpoint. AE is equal to BE. So, but AE is equal to BE. These two are equal. This is given, isn't it? AE is equal to BE. But here you have proved that AE is equal to CD. So, can I write CD and DE are equal? Yes. Why? Because according to the axiom, things which are equal to the same thing are equal to one another. So, BE and CD are equal. And one more thing, see properly, these two angles are equal. These two angles are equal. Which type of angles these two are? See, this is a figure like this. Like this is the figure. Which type of angles these two are? This is inside the shape, isn't it? So these two angles are alternate angles. So they are alternate angles. Alternate angles are equal means, can we say these two lines are parallel? Yes. So we can write, here also I write AE is equal to CD and AE is equal to BE, and one is A is equal to BD, and these alternate angles are equal. So AE is parallel to CD also. So how to write this? AE is equal to BE, and because of this and AE is parallel to CD. Why? Because alternate angles are equal. Alternate angles are equal. Which are alternate angles? These two angles are equal. Now see properly, AE is equal to CD, but AE is equal to BE. AE is parallel to CD. So what? By these three things, what I can say? I can say that CD is equal to BE and CD is parallel to BE. So CD is equal to BE is equal to CD and BE is parallel to CD. These things I can write by these three things. AE is equal to CD and these two angles are equal. AE is equal to BE also. So AE is, by these two angles I can say AE is parallel to CD. So at the end I can write BE and CD are equal and BE and CD are parallel. Now BE and CD are parallel. These two lines are parallel. Go to your theorem number 7.8. What it says? It says in any quadrilateral, you can see here quadrilateral picture. Which is a quadrilateral? B, C, D, E is a quadrilateral. In that BC. So first thing I want to write is EF is parallel to BC. That is first. This is I'll take number 1. By 1, EF is parallel to BC. Because reason ED is parallel to BC. ED is parallel to BC. Because of that I can write EF is parallel to BC. This is your number 1. And number 2, what you want? EF is half of BC. So ED is equal to BC, isn't it? ED is equal to BC. ED is equal to BC. But ED is equal to what? EF plus FD. EF plus FD is equal to BC. EF plus FD is equal to BC. Now EF and FD are equal, isn't it? EF and FD are equal. That is your construction. Here you did EF is equal to FD. So in the place of FD, I will substitute EF itself. So what it will become? EF plus EF is equal to BC. EF plus EF, that is 2EF. 2EF is equal to BC. Now shift 2 to that side. What will you get? EF is equal to half BC or BC by 2. EF is equal to half BC. So whenever you learn midpoint theorem, that midpoint line, the line joining the midpoint is parallel to the third side and it is half of the third side. This is called midpoint theorem. This theorem we are going to use to solve the next exercise problems. Let us go to next theorem 7.10, but here only statement is required to solve the problems. Proof does not require, so only statement. Theorem 7.10, the line drawn through the midpoint of one side of a triangle, is parallel to another side, bisect the third side. Now here the same figure, students. We are on E and F for the midpoint it is mentioned, but here the line drawn through the midpoint of any one side of a triangle. E is the midpoint of a side of a triangle AB and parallel to another side. That line drawn is parallel to another side, means whatever line drawn here, EF, that is parallel to BC. Then you have to prove F is the midpoint. In your previous theorem it is given these two are the midpoints. You have to prove these two line joining these two midpoints is parallel to the third side. Now here it is given E is only the midpoint and the line drawn is parallel to BC. That is also given. You have to prove F is the midpoint. So that is the means that theorem is true, students, but proof does not require. If you take one point midpoint and it is parallel to another side, then you can say other point is also the midpoint. That is the theorem number 7.10. Proof does not require. Only statement is required to solve the problems. Now let us move on to the exercise, students. Exercise number 7.2. In this first question, what is given? ABCD is a quadrilateral. ABCD is a quadrilateral. So just draw one quadrilateral ABCD. ABCD is a quadrilateral that is given for you, in which P, Q, R and S are the midpoints of the side AB, BC, CD and DA. In that order only you have to mark. P on AB. P is on AB, midpoint, that is P. Then Q is on BC, Q, and R is on CD, and S is on DA. You have to mark the midpoints. And AC is a diagonal. So join the diagonal AC. AC is a diagonal. Now you have to show that SR is parallel to SR, join this student. SR is parallel to AC and SR is half of AC. SR is parallel to AC and SR is half of AC, that you have to prove. And PQ is equal to SR. So join this also. PQ is equal to SR and PQRS is a parallelogram. PQRS. So join this. PQRS is a parallelogram. This you have to prove. Now let us write given first. What is given in the question? Given that ABCD is a quadrilateral. ABCD is a quadrilateral. Then P, Q, R, S are the midpoints of AB, BC, CD and DA. P, Q, R, S are the midpoints of AB, BC, CD and DE. That is given. You have to write in order itself. P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD and S is the midpoint of DA respectively. Respectively means in order. Respectively. What else is given? AC is a diagonal and AC is a diagonal. AC is a diagonal. This much is given for you. What you have to prove? You have to prove these three things. So, first of all, I told while explaining the midpoint theorem, whenever it is mentioned the midpoint of a triangle, then you can go to your midpoint theorem. Now see properly, whenever you join a diagonal, then the quadrilateral is divided into two triangles. Which are the two triangles? One is ABC, another one is DAC. Now, first go to the triangle, upper triangle, because I want SR and AC. So go to the triangle DAC. In triangle DAC, now see only this much. Don't see this part, student. Don't see this part. Only see this much. Now, these two are the midpoints. If you join the midpoints of two sides of a triangle, which are the two sides? DA and DC are the two sides. The midpoint of two sides of a triangle. Then the line formed is parallel to the third side. Which is your third side? AC. And it is half of third side. So directly by midpoint theorem you can write this. So to prove you have to write those three things, students. One is SR is parallel to AC and SR is equal to half AC. Second one you have to prove is PQ is equal to SR and third one you have to prove is PQRS is a parallelogram. Now I am going to prove the first thing. Proof. First thing. In triangle. Which triangle I am going to take now? DAC. In triangle DAC. S, R are the midpoints. Of which two sides? AD and DC. S, R are the midpoints of AD and DC. So what can I say? By midpoint theorem, SR is parallel to AC. So therefore, SR is parallel to AC and SR is equal to half AC. SR is parallel to AC and SR is equal to half AC. So by midpoint theorem, MPT, this is not mass PT, students. MPT means midpoint theorem. By midpoint theorem, I can say SR is parallel to AC and SR is equal to half AC. So first proof is over. Now go to second proof. Second proof. For this you have to take this triangle now. Down triangle. Same method you have to do, students. P, Q. Now here A, B, C. In triangle A, B, C. P and Q are the midpoints. So what can I write? PQ is parallel to AC and PQ is half of AC. In triangle ABC, P, Q are the midpoints. Midpoints of AB and BC. So by midpoint theorem, what can I write? PQ is parallel to AC and PQ is half of PQ is equal to half of AC. But here, why I am using this? Because you don't need to prove this, but you want PQ is equal to SR. In the first proof, SR is parallel to AC and SR is half of AC. SR is half of AC. Proof 2, PQ is half of AC. So can I write PQ is equal to SR? Yes. So by 1 and 2, PQ is equal to SR. So I can write PQ is equal to SR. This is by the axiom. Axiom, things which are equal to the same thing. PQ is equal to half AC. SR is equal to half AC. So both are equal to half of AC. I can write SR and PQ are equal. Now I want third one. PQRS is a parallelogram. Again go to the same proof. SR is parallel to AC and the PQ is also parallel to AC. Can I write SR is parallel to PQ? Yes, because both are parallel to AC. So PQ is parallel to SR. That is also by the axiom. PQ is parallel to AC and SR is also parallel to AC. Things which are parallel to the same thing are parallel to one another or equal to one another. So I can write PQ is also parallel to SR. PQ is parallel to SR. That is line parallel to the same line. What you learned? Theorem. SR is parallel to AC. PQ is parallel to AC. So these two are the lines parallel to the same line. So I can write these two lines are also parallel. That is lines parallel to same line. Lines parallel to same line. Now PQ is parallel to SR and PQ is equal to SR. You got one pair of opposite sides are equal and parallel. Then can you say the quadrilateral is a parallelogram? Yes. By theorem 7.8, you can say PQRS is a parallelogram. So by theorem 7.8, that is now first one and second one is proved. Now third one, PQ is parallel to SR. PQ is parallel to SR. So if one side is parallel, here PQRS is a quadrilateral. If one pair of opposite sides are parallel and equal, because PQ is equal to SR also, PQ is parallel to SR also. So one pair of opposite sides are equal and parallel, then the other pair is also equal and parallel by theorem 7.8. So by theorem 7.8, what can I write? PQ is parallel to SR. So other pair, which is that other pair? SP is parallel to RQ. SP is parallel to RQ and SP is equal to RQ. These two things are equal. So SP is equal to RQ and SP is parallel to RQ. Here PQ is parallel to SR